Welcome to the basics of network addressing. This video covers the purpose of IP addresses and their masks, and how IP addresses are obtained by network devices. A host needs an IP address to participate on the Internet. The IP address is a logical network address that identifies a particular host. It must be properly configured and unique in order to communicate with other devices on the Internet. An IP address is assigned to the network interface connection for a host. This connection is usually a network interface card, or NIC, installed in the device. Examples of end-user devices with network interfaces include workstations, servers, network printers, and IP phones. Every packet sent across the Internet has a source and destination IP address. This information is required by networking devices to ensure the information gets to the destination and any replies are returned to the source. An IP address is simply a series of 32 binary bits, ones and zeros, grouped into 4 8-bit bytes called octets. An IP address in this format is hard for humans to read, write, and remember. To make the IP address easier to understand, each octet is presented as its decimal value separated by a decimal point or period. This is referred to as dotted decimal notation. The logical 32-bit IP address is hierarchical and is made up of two parts. The first part identifies the network, and the second part identifies the particular host on that network. Every IP address is paired with a subnet mask. The subnet mask is also a 32-bit number that is used by hosts to separate or mask the network portion of the address from the host portion. As an example, if a host has the IP address of 192.168.5.11, the first three octets, 192.168.5, identify the network portion of this address, and the last octet, 11, identifies the host. This is known as hierarchical addressing because the network portion indicates the network on which each unique host is located. Routers outside the local host only need to know how to reach other networks. Only the local router needs to know the location of each of its individual hosts. So we know a host needs an IP address and a subnet mask, but one question we need to answer: how does it get one? A computer can get an IP address either dynamically or statically. If statically, a network engineer assigns a specific IP address to each computer. Notice in this case the IP address and subnet mask are being configured, as are the default gateway and the preferred and alternate DNS servers. Static IP addresses have some advantages. For instance, they're useful for printers, servers, and other networking devices that need to be accessible to clients on the network. If hosts normally access a server at a particular IP address, it would not be good if that address changed. The second way for a host to get an IP address is dynamically. Dynamic Host Control Protocol, or DHCP, provides a mechanism for the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. DHCP is generally the preferred method of assigning IP addresses to hosts on large networks, since it reduces the burden on network support staff and virtually eliminates entry errors. Imagine having to physically configure hundreds or thousands of computers. This would be highly impractical. I hope it was helpful to see why every packet sent across the Internet needs a source and destination IP address and a subnet mask. Also, the variations of how they can be assigned, either statically or through DHCP. Networking professionals also practice variations on subnetting that include variable length subnet masking, or VLSM, and classless interdomain routing, or CIDR, which are needed in large networks.